Hi guys, this is GK from GK Marine Tech. Today, next lesson is in electricity RMS value. The famous word, maybe you heard about it. What is RMS? How to calculate? What is the purpose of that? Why we want to calculate this RMS value in our electricity? So we will see about detailing. So before start thinking about the RMS, we have to know about average value. What is that average value? Because you know between the difference between alternate current and direct current. Direct current, the voltage and current is very steady. So if you want to calculate the power equal to voltage into current, you know it. So very easily calculate any time. Okay. But in AC cycle, alternate current, alternate voltage, the voltage is not steady. So which voltage you will take for the power calculation? Because sometimes the voltage is 0, sometimes the voltage is in the peak. So simply, normally arithmetical calculation, what we used to do? We used to average this because the power is the area under this curve. Okay. So what normally, normal method, in mathematical method, we will take, divide this curve into equal parts and we will measure the voltage of the curve, all the equal parts, and we will take it as an average. Okay. So you will get the average voltage and distance you can, if you know, you can easily calculate the power. So for that purpose, initially I told you the first they invented in 1800 years, they invented DC only. After 55 years, Tesla, he discovered this, he invented this alternating current. It is very useful to us. Okay. So now 55 years, the people used DC power, DC everything calculation the DC. So suddenly we cannot switch over easily because all countries they followed that DC voltage, DC power calculation. So what we are thinking, we have to match with that. We have to, we have to adjust with that the DC power. Then we have to introduce the AC in place of DC. So that is why they are comparing with the DC power. Okay. So DC power wattage everybody know. If suppose one company they sold you one motor, this is this much horsepower or this much wattage, this power in DC. But the same wattage unit, you cannot mention that AC wattage and DC wattage. Wattage power should be power, right? So whether it is a DC or whether it is a AC, the power should be wattage. So we cannot differentiate DC wattage is different, AC wattage is different. So how we are converting this AC cycle equivalent to the DC, then we are calculating the power. So for that reason only this RMS has come. So we will see how the RMS is developed and what is the significance in that. So okay, the voltage now you understand, no? For finding the power formula or for telling the voltage, which we cannot say the peak voltage because peak voltage is not available all the time. All 180 degree the peak voltage is not available. But the problem now, half cycle is in the positive side, half cycle in the negative side. So it's very difficult to get average because here you are getting a positive voltage, here you are getting the same curve in the negative region. If you add both, you will get as answer 0. So you cannot get the average value like full cycle. So what we are going to do, we are going to take 1 half. Correct. Average value always they will do for the 1 half because they want only the average voltage. Right. So they will calculate they will consider only the half cycle, positive cycle, and they are the other half cycle we are considering the similar way it is in the negative side. There is no change in the curve amplitude. Okay. So we will see how to calculate the average value. We have to divide this half cycle. First we will divide full cycle. Okay. Then if you add all the values of here, then the answer will become 0. Correct. Because here all plus volt. Every part in this division should be equal. Okay. Same parts you have to divide, equal parts. Then only you will get the average. So every point you are measuring the voltage, how much is there. So that voltage you add on. See, like this. V1, V2. I think you can see V1, V2. We are up to here. The voltage is same. After next cycle also most probably the same voltage will be the same. in the descending order. This will be in the ascending order, this will be in the descending order, this will be in the negative direction. Okay, but if you add all points, you will get answer 0. So what we do, we calculated only the half part. Half part we don't consider. So half part we are calculating up to V9, V10 and here V20. Okay, so I didn't mention all points because the same value is going to come in the other side. So we are calculating 20 equal parts and every part we are measuring the voltages. Okay, so that voltage is average. Average, you know that arithmetic mean. How you do average? You add all the points, divide by the number of division, how much you divided the curve. It's very, very simple. So V average equal to V1 plus V2 plus V3 up to V20. Correct? I have shown here V9 only, but here still some more points are there. So I didn't show it, but all the values you have to add. How much division you divided, you have to add all the values and divided by number of division. Okay, number of division is 20. So you will get some voltage that is called V average. That normally the peak voltage is this one. Peak voltage is what is that? Peak voltage is V9. V9 and V10 is the peak voltage. That is a V peak. In a few seconds we will talk about the peak voltage. What is the peak voltage? Peak voltage is the maximum voltage the curve is reaching. So the peak voltage and this average voltage, there is a relationship. After calculating this arithmetic mean, you will get the relationship with peak voltage and this one. It is 0.637. This is only for sine wave. This will change, depends on the waveform. If the waveform is square, that is different. If waveform is triangular wave, that is different. So it is only for this 0.637 into peak. If you calculate, instead of dividing all equal parts and adding all voltages, it's very, very difficult, you know. So they are giving a simple formula. If you know the peak value, if you know the peak voltage, then just multiply by 0.637. That will give you the average voltage. Very simple. Direct formula. No need to calculate like this. This is the method they calculated and then they convert this into the formula, constant. Okay. So this value is, you can take it as a equivalent value, which is the same power produced by the same DC. Okay. Because we cannot take it as a maximum power, because all the places is not there. That is why we are taking the average. And how much power produced in the average voltage, that is voltage into current, average voltage, that power is same, equivalent to the same amount of power produced by DC. You got my point? Okay. Now we will think, but this is the average point. But here what is the problem is that only we are considering off cycle. We are not considering the other off. We are taking this granted, that is a similar positive cycle is coming to the negative. But if you want to consider full, we make it a perfect, and also it's an arithmetical calculation, correct? So arithmetical calculation is different. What they decided, the same voltage, same current, how much power it is produced. Okay, if you take for example, we will take the bulb. We will see RMS value. That is called RMS value. That's why they found the RMS value. There is a little difference between average value and RMS value. RMS value also average only, but little different way they are calculating the RMS value. So how they are doing? We are taking voltage or current. Both are sine wave only. So for current also you have to take RMS current, and voltage also you have to take RMS current. Okay. So we will take, for example, 2 lab test. One bulb, same bulb, there is no difference, and battery we connected, through battery the bulb is glowing, and here AC source, same bulb, no power difference, no resistance difference in the bulb, so everything is same. Only here we are giving DC source, here we are giving AC source. I am taking current. After that you can take voltage also, so both are same. We are talking about the current. Okay. So current, if you understand, the similar way voltage also there. So don't get confused if we are taking the current. So same current we are giving. See, you can see here, same current, both the side we are given. But what is happening? The bulb is glowing, but this bulb is not steady glowing. You know what is the reason? Because of AC is not steady. Periodically it is going 0 and then going negative direction and then again coming to 0. So that is why it is flickering. Just for understanding, I made it. So definitely when bulb means what? It is converting the electrical energy into heat energy and light energy. Okay. So light energy we are not bothered. So it is creating heat. So heat is equivalent to the power. So all the power we are calculating into watts. Okay, watts or horsepower. So watts only we are calculating. Watts is the same unit for heat, same unit for power, whatever it is. So now this look like this bulb is a heater, not as a bulb, not is a giving light. It is a heater. So how much heat it is dissipating? How much this bulb is heat dissipating? You see how much is dissipating? See, this bulb is dissipating more. Right? Because this here the current and voltage is steady. There is no zero. That is why here the heat dissipation is more. The same voltage, same current, no difference. Right? So heat dissipation is more. But here you see heat dissipation less. You know why? Because sometimes the bulb is switch off and switching on again, and it is going to the peak. So that definitely the heat generation from this AC circuit is less than heat generation from the DC circuit, that is not equal. You understand? Now we want to consider the voltage. If it is a watt or voltage power calculation, it should be same. No? The same power, same current, same amps. If you give same power heat, it should generate. So what we have to do for making the same one? Now I am going to increase this current to some high level to become these two heat generation equal. You got my point? To make it equal, we cannot make it equal now. How to make it equal? You have to increase the current to some high value so that one time it will become equal. I increase the current. Now you see both are equal. Right? So this is the equivalent AC to the DC circuit. Now we got it. DC circuit is fixed. It is already invented. So now we are finding the new AC circuit, we are comparing and bringing that AC circuit equivalent to the DC circuit. So what we are doing, we are increasing the current so that the heat generation should be same. You got my point? Heat means power. So power should be same. Now how much current you increase, this much current you have to get this much output, DC output. Okay. So if you give this current will be RMS. That is a ratio. Between these two, this is equal, and comparing these two, this is the current we given to AC circuit, this is the current we given to DC circuit. Now we have to compare these two, because for attaining the power, same power from the DC circuit from this much current, AC circuit we are giving more current to achieve the same output. Now how much is increased? That is the maximum peak voltage. This is the peak voltage, right? This is the peak voltage. This is the base I am taking, and this is the peak voltage. I peak, current peak. Even voltage are the same. Okay, I am talking about the current only because of some purpose I am selected the current first. Voltage is similar way we can calculate. So this is the peak current, but this current equivalent DC current, that current is known as RMS, IRMS. Okay, for this peak current, this value is RMS value. You want my point? But this is a practically I am telling, but we cannot measure like a practical. I will tell you the formula and method how to calculate directly. Okay, so this peak current, normally the peak value into some constant, like average value equal to 0.637 I said, no? Similar way here, RMS value equal to 0.707 peak. So it is little more than RMS value. This practically by experimental they found this. So average value if you calculate, it will be less. So they calculated like this. So we are consider this is the standard for all over the world. So whatever electricity now it is AC only. So for power calculation they are taking this RMS value only. They are not considering average value. They are not considering the peak value. Got it? So this 0.707, it is a formula method is from integration, the sine curve and all they are bringing. We don't want that much level, but you should know about 0.707 is for RMS value, 0.637 is for average value. But average value initially they found, after that they found that is not exactly correct. So they modified to RMS value. Now all system is RMS value only. Okay. So how we are calculating this RMS value? What is this RMS? What is the meaning of RMS? It is a root mean square. It is a root mean square. RMS, root mean square. Root mean square means what? It is a step of calculating the value. Average value, you know, you add all the vertices and then divide by number of equal parts and you will get the average. That is a mean. Okay. But this RMS value is not like this. So in what method we are calculating the value from the individual vertices, vertical lines voltage in the sine curve? That method they mention it, shortcut they mention it root mean square. Otherwise there is no direct meaning of this. Okay. You know root means square root, mean means average, square means is a double square. Okay. So this is the method we are doing. So we will see how we are calculating the heat developed. Heat developed should be equal to power. Okay. I told you bulb we are not considered as a light generating system. We are considered the heat developing equipment. So the heat is equivalent to the power. So power formula, what is that? What are the values? If you have voltage and current, then power equal to V into I. Power equal to V into I. And you heard about cos phi. That is the next class we will talk about the cos phi, power factor and all. Now you don't get confused with the cos phi because we are taking only resistive load. Still we are not coming to the inductive and capacitive load. Next lesson we will talk about the power factor. Now you just imagine it is a resistive load. We are calculating V into I. Power factor is 1. Okay. Power factor is 1. Okay. Now V into I. This V, as per Ohm's law, V equal to I into R. You know that? As per Ohm's law, V voltage equal to I into R. So this place, this V, what I am going to do? This in place of V, I am going to put I into R, because I want resistance. I don't want the voltage because voltage is also varying, right? But resistance is not varying, bulb is same. So I want to convert this into one variable. I cannot multiply both things varying. Voltage also varying, current also varying. I cannot calculate, right? So I want to make it one variable and one constant. The constant is R because bulb is same. R means ohms. So I multiplied like this. I converted this V into I into R as per Ohm's law. So now I into I square, R is R. Now R is a constant. So constant will not change anything because that is same for both sides. Okay. So we will leave the constant. We will take only this I2 part, I square part. Correct. So the power is directly relation to I square, not I. Power is relation to directly proportional, you can say directly proportional to I square, not I. Correct? Like V square also you can put V square by R. Instead of this, we can put V square by R divided by R. That is for calculating the VRMS. There also 1 by R is a constant. So constant part we will eliminate. We will take only the I square part. I square means we have to consider I square, not I. So what we are going to do, we will calculate the same way to off cycle. Calculate even full cycle also you can take. See, up to you. So you can take full cycle also, but you have to calculate the I1, I2, I3, I4, I9, everything. All values, all division, how much current you have to calculate. But in average what we did, we added all together divided by number of parts we divided for making the average. Number of parts is required. How many divisions you divided, that is important. But we added in the numerator, we added all the current value. But instead of that, here what we are going to do, the same value, what we are going to do, instead of adding I, we have to add I square. Correct? We have to add I1 square, I2 square, I3 square, I2 square, I20 square. The same one, what we did it in the average, we added only I1, I2, I3, I4. Here, I square plus I1 square plus I2 square, everything square. Why we square? Just now only I told you, the power is directly proportional to I square or V square. If it is a V, then V1 square, V2 square, V3 square. If it is a I, it is I1 square, I2 square, I3 square. But division is same. Okay, after average, why we are making it as a square root? Because we made it I. The value will be in the square range, So final value, you have to go back to the original value. So we have to make it the square root because we have to cancel this square. Correct? So after average, you have to cancel the square so that you will get the correct value. Otherwise, you will get the power square. Correct? So that is why we are having two items in the mean, before square, after that square root. This one only they mentioned this, root mean square, because inside we are making square. I will show you how it is. Okay, this value is approximately equal to, it is equal to 0.707 into current peak. If it is voltage peak, value same, 0.707. For sine wave is same, be careful. If it is a triangular wave, a square wave is different. It is only for, this calculation is only for sine wave, because we are dealing with only the sine wave. Not the square wave, very easy, because it's having some constant area, easily you can calculate. Okay, so now you know now what is the RMS value. Now why we are calling it as RMS value, we will see. So we are making 3 steps for calculating the RMS value from the curve voltages, I1, I2, I3 voltages you got now, data. From the data, how to calculate the RMS value, you see, first step, in this last one you take, not the first one. Here they put it in reverse. So first one is a square. The root, RMS means root means square. So we have to do square first, then mean, then root. Reverse manner you have to do. So first I made it square. Square means what? I will make I1 square plus I2 square plus I3 square. All squares I added. This is the square value, right? So after adding, second step, mean. Second step, mean. Mean, you know, you already added, divided by number of equal parts, 20. Okay, but we didn't take I1, I2, we took I square. So we had to cancel this square. Okay, so for cancel this square, you have to make it root. See, square root. Root means square root. So square root, what you have to do? You have to make it square root. So this is the method to calculate the RMS value, but you need not calculate. If you know the peak value, the peak value into 0.707, it will give you RMS value. If you take the maximum voltage, peak voltage, then for sine wave, you multiply by 0.707, then you will get the VRMS. So power equal to VRMS into IRMS. RMS value only you have to calculate, right? Okay. So now, see, now how they change this term, root mean square. The last one will become first, center one center, and the first one will become last. And the value is 0.707. Okay. Okay. Now the difference you see how it is. This is the average value. Average value is 0.637. 0.637 voltage peak. Correct? Voltage peak is there. This is the peak. Okay. This is the peak. So this peak into 0.637, if you put it, it will come here. This is the voltage of this sine wave, average value of the sine wave. But we don't want average value because average value is very less. So they, for commercial purpose and all, they want to prove. So no, we are making more power because it depends on the power, your price and everything will be more. No? So that is why they calculated experimentally and they found VRMS. VRMS will be little more value. So power will be more, correct? So 0.707 is the RMS value that only be considered to all your calculation purpose. You got my point? So average value we are not considering, we are considering only the RMS value. And one more thing, Form factor, maybe you heard about the form factor. Form factor is nothing, it is ratio between average and RMS value. Ratio between RMS value and average value. This is for some calculation they made it. This form factor will be vary, depends on the shape of the curve. If suppose sine wave, this will be like this. If it is a square wave or triangular wave, it will be different. Okay. So the form factor is vary according to your waveform. That is why it's called form factor. Both are voltage, so it is not having any unit. And here 0.707 is a constant, here 0.637 is a constant, we peak same only. So if you divide it, you will get it 1.11. 1.11 is the form factor. It is not having any unit, it is a ratio between average value and RMS value. The form factor, because we are not going to use this form factor anywhere, it's a design purpose, but you people should not get confused with the form factor. I will tell you, last thing I will tell you, what confusion normally along with the electricians regarding this form factor. Because we are not going to do anything in this. So don't think any calculation related, but it's a different purpose, we are a design purpose, we are taking it as account. Okay, next, RMS value, AC power equal to, I told you, AC power how to calculate? VRMS into IRMS in resistive load. If it is an inductive load, then power factor also have to multiply. Okay, so VRMS into IRMS. Okay, now how to calculate? Very simple. Your multimeter, your ammeter or voltmeter, whatever you are using in the industries, all shows only RMS value. All shows only RMS value. It is not showing where nothing will show in the peak value. So where to find the peak value? If you want to see the peak value, you have to go to the oscilloscope. Oscilloscope is the instrument to show the waveform. Instead of measuring the voltage, it will show the sine wave only. So in that you measure, you can see the peak voltage. So oscilloscope only will give the peak voltage, and your multimeter and ammeter, voltmeter, whatever you are using in the chip or industries or your workshop, that all will give you RMS value only. You have to understand that. That is peak value into 0.707. You understand? So we will consider this is a voltage. Why we are considering the peak voltage? Because if you rectification, you know, no, AC into DC. So if you convert the AC into DC, that time the DC will become equal to the peak voltage, not the RMS value. In that place you will get confused. Why the voltage is increased? For example, 230 volt AC is there. You convert AC into DC by rectifier diodes and capacitor. Then the output will become 320 volt DC. You imagine, you give only 220 volt only, but you are getting 310 volt. How it is increased in DC? DC will take the peak voltage. So in that cases you will get confused. You may be thinking something wrong. Why we are input only 220 volt AC only we are giving, but the DC output is coming 320 volt. How it is coming? That is because of DC will store only the peak voltage, but your multimeter showing only the RMS value, and our power consumption also RMS value. You got my point? So that is why AC power equal to AC power, DC power V into I. There is no RMS. Okay, and inductive load. If it is an inductive load, then you have to multiply with cos phi, and it is a 3-phase, then you have to add one more √3. That all future videos one by one we will see. Okay. Now, I will ask one question. You notice the power supplies 11 kV, 440 volt, 220 volt, 110 volt. What is the similarity in this? All are divisible by 11. Correct? All are look like it is divisible by 11. So people will say this is because of the form factor. No, this is not a form factor. Form factor is 1.11. No? So they are thinking 100 volt into the multiplication, it should be divisible by form factor. No, form factor nothing is doing with this. This doubt so many electrical officers they have, and they are considering because of the form factor only the value is coming is a double digit, same digit. No, This one, why it is coming? EB is the contractor. They are giving a electrical supply to you. If you buy 1 kg of sugar from the shop, what he will do? He will put some little amount, add after measuring 1 kg, he will put little bit above and then give you. Why? Because after buying, you should not go and weigh in your home and it is showing instead of 1 kg little less, 50 gram less, then you will go to the consumer court. Because I asked for 1 kg but you gave 950 gram. So for safe side, the supplier, what did they do? The little bit they added. So if anything less also, you will compensate with that, added the little bit sugar more than that. Correct? The similar way, they want to supply 400 volt only because they want a round amount. They want to supply 200 volt, they want to supply 100 volt, they want to supply 10 kV. But after passing through the transmission line or connection, so many places there may be the losses. And when it is reaching your industry or your home or where you are using, there you will get less than that 400 volt because the EB is having a contract to supply 400 volt. Correct? Less than 400 volt you should not supply. If it is supply, then we can put a case on them. Why you supply less volt? Because my equipment are getting spoiled. So that is why for making safe side, they always added 10% extra to the contract voltage. Correct? It is a 400 volt plus 10%, 200 volt plus 10%, 100 volt plus 10%. That is why it is coming like this. 10% they added with the contract agreement voltage along with that, and they are giving so that you will not get a loss. Now you understand why this is like this. It is not because of form factor. Don't confuse yourself. It is because of 10% additional voltage, additional current, additional voltage, current, not a current, additional voltage the EV is supplying or your machinery is producing, your generator is producing to safer side to get the correct value, more than your agreement value. It should not be less than your agreement value. That is why it is there. Okay, now you got a lot of information about RMS value, how we are calculating the power, what is the purpose of this form factor and average value, peak value, what is the relation between them, everything you know, and why also you know. So this class, I think you got a lot of information. Maybe some electrician senior staffs, they know a little bit, but even I hope you refresh the things again. So little useful video, I hope. Give in the comment and I will, according to depends on the comment, I will improve and then add more points in the future lectures. So we will end up at this point. We will see in the next lecture soon. Thanks for watching.